Hi everyone, it's Ben. I'm in Montreal for Confu, got here on Monday evening, arrived at the hotel, unpacked, built my door, and it wasn't working. The NFC card had fried. I'm not sure what's gone on yet, I haven't had time to look into it, but I popped to the local electronics store and bought some spares. They didn't have the same NFC card, so I've had to re-architect the hardware slightly and some of the software as well. So here we are, it's working. I'm ready. In about 6 hours I'll be giving this talk at Confu on stage, and I thought I'd create a video beforehand just to do a run through and show you all how it works. Okay, so let's have a look at the hardware first. If we come around the back here, you'll be able to see the back of the door. The main mechanical part is this lock here. So we have a little wooden bar that gets moved by a servo up in this spot here. So this servo will pull the bar left and right. That will then obviously unlock the door. The servo is controlled, so there's a little PCB breakout here which plugs into the Raspberry Pi. So the Raspberry Pi controls the servo through some of the pins on the left here. There's this little bit of extra cable down here that used to be connected to the old NFC card, but obviously that's not working anymore. From the Raspberry Pi we have a serial cable coming up to the Arduino Uno, and this is connected to the NFC card on the other side. And then we have the NFC card over here, the only publicly accessible component, because obviously we don't want anybody to have direct access to any of the mechanics behind here, any of the controlling, processing stuff. With access to that you can short pins and automatically unlock the door. So from a security perspective, the NFC reader is essentially just a data reader and throughput, which is publicly accessible, sends it through to the Arduino, down to the Raspberry Pi. The Raspberry Pi gets the JSON web token off the card, processes it, and if valid, will unlock the door. So let's have a look at the code behind the scenes now. So the first aspect is the Android app. The Android app will connect to Auth0 in order to get a JSON web token and then write it onto one of our NFC cards. So the app itself is fairly straightforward. We have a couple of buttons in the user interface. The first one is the login button. We'll see that in a second. When you click it, we basically call login. This uses basically out of the box Auth0 code. The second button is for writing to the card. Essentially, when we click on that, it's going to come through, and assuming everything's okay, we're going to write the access token onto the tag. Now, one of the issues that I faced was that the NFC tag that I got from the local hardware store isn't actually, the user store area isn't large enough to store a full JSON web token. So I've had to create a pared down JSON web token that's equally as valid, but it's missing things like the issuer and the issued at timestamps. It contains the minimum amount of information, which is basically the audience. So the door needs to know that it is the audience for the JSON web token, and also the expiry, because obviously the door needs to know whether or not the token is still valid. So I've made a small change to the application compared to what's in the GitHub repository. Normally we would just get the access token from the credentials that are passed back as part in the login process from Auth0, but instead here I'm then converting that to a fixed JSON web token, and this is basically what I was saying, the audience and the expiry, and the expiry is for this Sunday, so it'll definitely work for the purposes of this video and the presentation this afternoon. So then, once the app has written the JSON web token onto the card, we need to read it off on the Arduino. So the Arduino uses the NFC reader, which is a PN532, and will then get the information off there, off the NDEF user store area. So I'm using the standard MyFair Classic memdump sample code that came with the Adafruit PN532 library. I've made some small modifications to it so that towards the end here, rather than dumping it to the screen as a hex dump, we're basically grabbing the data from the user data area of the NFC card and extracting the path that it represents the JWT, or the JSON web token, and then we basically print that out to the serial output. The serial output is then connected into the Raspberry Pi, and the Raspberry Pi can retrieve that information. So there's a couple of things here in that the JSON web token will be prefixed with JWT:\space. That's in order to allow the Raspberry Pi to be able to detect when the message contains a JSON Web Token more easily. We've also got a little bit of other information being sent through. So there's a dot that's sent every now and then, which basically means I'm active, so the Raspberry Pi can detect that there is actually a signal coming through. And the other part is because the Arduino is fairly slow and the amount of data on here is quite large comparatively, it actually takes a while for the Arduino to read the data off. So we have another bit down here where while we're processing the stream of data that's coming through, so the Arduino won't receive a string, it'll actually receive a character stream, and as we're processing each character we're going to output an exclamation mark on its own line. The purpose for this again is as the Raspberry Pi is monitoring the serial bus, it'll be able to see the exclamation mark and infer that there is some kind of activity going on. The final part is then the Raspberry Pi code. So if we jump over to that, we're connected here directly to the Raspberry Pi via SSH. So the Raspberry Pi is connected to the Wi-Fi network, and if we look in the opening doors repository, which is also on GitHub, there are two files in there, poll tags and poll USB. So we're going to be using poll USB for this one. Poll tags is the one that was working previously with the other NFC reader. And if we look at this code here, essentially we're just using serial. We're going to be processing JSON, doing some time checking, doing JWT decoding, and then talking to the I/O ports of the Raspberry Pi in order to control the server. So we have our public key in here, which is what we're going to use to verify the JSON Web Token. We connect it to our serial bus, we define some port pins for the servo, and then we go into our loop. So essentially it's fairly simple. So the code part is fairly self-explanatory. We read a line from the serial input. If it's a full stop, then that means there's no activity currently happening. So we'll just print that out so we've got something in the logs. We'll set the status to inactive. There's nothing that needs to be done at the moment, and we make sure the door is locked. If the input is an exclamation mark, then unless it's already pending, we set the status to pending, and we print out reading key, so that we know from the logs that something's happening. It's just that it's going to take some time for the data to come in. Then if the input starts with JWT :space, that's obviously going to be our token. So we'll strip off the first 5 characters, and the remainder is the token. We'll use the JWT class to decode that, and assuming it's valid, it'll continue. If it's not valid, it'll throw an exception. If it continues, then we grab the timestamp for now, the timestamp from the expiry of the token payload, and work out how much time is remaining. And again, if there's no exception, we're still good to go, so we can say the door can be unlocked until a certain time. We unlock the door, and then we wait for 5 seconds. So that 5-second timer is so that when the door unlocks, if I take the card away, it doesn't lock straight away again. It gives you time to actually open the door. Looking at exceptions, if there's an expired signature, we're going to say that the access is denied. Obviously the time has passed, token is expired. If there's a decode error, so the information that comes through is a broken JSON Web Token, we're just going to print out that it didn't look like a JSON Web Token. And this can happen if I put the card up and take it away before it's finished reading, or if somebody puts up a different kind of card that doesn't contain a JSON Web Token. If the data that comes through somehow is not decodable, then we'll print that out to the screen. And then we just start our loop at the bottom there. So let's run this. And we can see that the first thing that's going to come through is going to be the dot from the Arduino at some point, which tells us that there's no activity, and we make sure the door is locked. So now if I hold my card up, we should be able to see it goes into receive mode, gets the JSON Web Token, and hopefully unlocks the door. Let's give that a try. The first part before we can even go to the door is we have our NFC tag that we need to program. So let's switch over to the app in question. We have this Open Sesame app. So this is the application, the Android application we looked at before. We click on the login button, which will then take us off to the Auth0 login system. Because I've already logged in before, it automatically returns me. The login button is then disabled because I'm logged in, and the Create Door Pass is enabled. So if I hold the card to the back and then press on Create Door Pass, we'll see at the bottom Door Pass created successfully. The JSON Web Token has now been transferred onto the NFC tag. Now if we switch back to the Raspberry Pi code, we can see over here the door is currently locked. So if I hold the NFC card up to the reader here now, we can see that it starts, we get the reading key notification, and then eventually we get the confirmation the door one can be unlocked until Sunday. There are quite a lot of seconds remaining, and you can probably hear the lock opening and closing. Let's have a look at how that looks like from the back of the door. So starting with the Arduino, we can see that when I hold the card up, the Arduino will start flashing quite heavily. So that's the point at which it's actually reading the data off the card, and it's going to output that through the serial out. So if I hold that up a little bit further, we can also see on the screen over here that it says card content did not look like a JSON Web Token. That's because I removed the card too soon and the data that got sent through obviously wasn't decodable. If I hold that up long enough and it starts processing, and we come down and look here, then the Raspberry Pi will read the JSON Web Token and bring the lock back into the unlocked position. So at the moment, when the 5-second time's out, it'll automatically lock the door again. We could change that to check to see whether there's a card still present. But for now, we have the card unlocking the door with nothing more than a JSON Web Token. If I take the card away again, next time it closes, it's just received another JSON Web Token, but it'll close and stay closed. So there we have it, opening doors with JSON Web Tokens. If you enjoyed this video, let me know in the comments below, subscribe, I'll see you in the next one. Cheers!